Next example of an optimization is when we're going to look at taking an 8 by 6, let's just say it's a sheet of cardboard, and we're going to cut the corners away from this cardboard and fold the edges up to where it forms an open topped box. So here we're going to cut the black little corners away. We'll fold it up along the green line so you'll see an open top box. Now, what's going to happen when we cut the corners away, we're going to cut a length, and we'll just call it X for lack of a better term. And because it's going to be an open top box and it's going to come out even, every place where we have this dotted line has to have that same length of X when we cut it out. So now, when we look at this length from here to here, this length is no longer 8, but it's 8 minus. Now, it's not 8 minus X because you're cutting an X away here and you're cutting an X away here. So it's 8 minus 2X. Likewise, when we cut away from here, this length would be 6 minus 2X. So our volume, which is what we're trying to maximize, we're trying to build the largest volume from this piece right here. So your volume for a box is length times width times height. Now, in terms of one variable, so we don't have to use a nasty looking product rule, we're going to have the length is 8 minus 2X. The width is 6 minus 2X. And the height is simply X. So we get to do some multiplication here. It gets a little bit nasty, but oh well. Let's factor out. No, let's not factor out. Let's just go ahead and tackle it. 8 and 6 is 48. We got negative 12x with negative 16x. That's negative 28x. And then plus 4x squared. And it's going to be times this x on the outside. So we distribute in, and I'm going to go ahead and write it in descending order at this point right here. So we get 4x cubed minus 28x squared plus 48x. That's how we would calculate the volume. Now, we want to take the derivative of this volume and set the derivative equal to 0. Again, that's where maximums and minimums occur. So, v prime is going to be 12x squared minus 40, no, one day I'll learn how to do arithmetic, 56x plus just 48. All right, from here, what is the largest factor of everything? 56 is not divisible by 12. So I guess 4 is going to be the largest factor in here. So let's factor out a 4. So we get 3x squared minus 14x plus 12. All right, now, chances are pretty good, and I'm not even going to try it, that will not factor. So I'll grab my calculator, which I put away, so you'll have to listen to me while I walk around and look for my calculator. Well, I found it pretty quick. All right, so I'm back on. Hope that y'all had fun thinking while I was doing that. But we need to set this equal to 0. Well, guess what we're going to need? We're going to need the quadratic formula. So it is 14 plus or minus the square root of 14 squared minus 4 times 3 times 12 all over 6. Okay, so this becomes 14 plus or minus the square root of, all right, 14 squared, 196, minus 12 and 12 is 144, and Coming up here, so we get the square root of 52 over 6. 52, 4, and 13. So 14 plus or minus 2 square roots of 13 over 6, which would be 7 plus or minus the square root of 13 over 3. All right, now you may be thinking, well, all right, we got two different answers here. 7 plus the square root of 13 over 3 and 7 minus the square root of 13 over 3. But let's look at what happens when we do this calculation. All right, so when I do 7 plus the square root of 13, and then subtract, I get, or divide by 3, I'm sorry, I get 3.53. And I'm just going to carry it out to the hundreds. All right, and then I do 7 minus, and I get 1.13. And you may think, well, the larger one would be better. But what happens when you cut the larger one out? This is 3.53. If we cut 3.53 away from here and we cut 3.53 away from here, that becomes a number greater than 7, which would overpass the 6. So it's impossible to cut 3.53 away from each corner. So the only option here is the 1.13. So the actual dimensions of this box, we'll go in and we'll say, okay, it's going to be 8 minus 2 times 1.13. And so we get that this is going to be 5.74. And then 6 minus that same quantity is 3.74. And of course, x is 1.13. So those would be the dimensions that would give us the maximum volume. If it asks for the maximum volume, at this point you would just multiply those three numbers together to get your solution. So that is what we're looking at as far as solving this problem out. I'm going to put one more example on it, and then after that I'll give the assignment. Don't forget to look through the notes. There are some really good examples in the notes from optimizations. I got some different types of problems on there, so please do look at those, and I'll be back shortly with the next video.